That is the one point I discussed NRE. Second, I cost the NRE cost already I mentioned. Second, size, power, then performance, and then 5 number is flexibility. And flexibility we have
Sir,
already. Yes.
sir, sir, are you presenting something, sir?
No, not yet. I have not started. Okay. So sharing option not started, but I will start soon. Is it coming now?
Yes, sir.
Yes, sir.
So now at least you can see here that already I mentioned earlier. NRE cost is a very important factor, crucial factor. Apart from all these things, few more applications are there that we have to consider. Okay, what are those part? Let's discuss one by one. First one is that time to market. This is the another feature, that time to market. That means if you are coming with the product the market lately, so you will get the less commercial benefit or maybe economical benefit. So time to market is the very important thing, and also and that depends upon the time required to develop the product, time to develop the prototype prototype and also the maintainability. That is also very important for all of us, that is maintainability. Then you will find correctness. Here you can say during the addition of new feature. Addition of new feature is a very important point, and correctness, safety, these are the also some important factor which influences a lot to the development of embedded system. Whenever you are developing an embedded system, you have to think about this part. Already we discussed that in embedded part, you know, one part is that our input, that means maybe sensor, and in processing unit input also there is a, I think, A to D converter like in this way. Then you will get the one processing unit. Then finally you go to the output, that it may be actuator plus DA to another converter like in this way you find. So today we are focusing that processing unit. Okay, that means you can say that this is a processor who is the perform the processor. It may be controller based, it may be general purpose also, whatever may be. My embedded system can be always made with the microcontroller. I am not these things, but for commercial viability it is most suitable. But using general purpose processor also we can do. In the last semester, I think we have discussed the control unit, processors, all these parts. So today we will make highlight a processors concept. Processor can be, we categorize like in this way. One is general purpose processor. I think we have studied. Another the application specific instruction processor, you can say. And another is the ASIC type processor, application specific integrated circuit. Okay, so these are the possible or viable three processors architecture. Am I correct? Are you getting this point? So mostly we are designing embedded system based on your requirement, where it can be used, where it can be used, where it can be used. Let's try to understand the applicability. Suppose I am mentioning, okay, one triangle area. This is my requirement. Requirement. If I view the GPP, how does it look? If it is a GPP system, if it is my GPP system, you will find that here you will find the architecture looks like in the GPP. Apart from all, it can do these tasks. If you view the ASIP view, it will be look like in this way. If you go to the ASIC view, it will be look like in this way. Can you Bishojit Ghosh? I am asking Bishojit Ghosh.
Yes, sir. Yes,
You
sir.
you respond my question first.
Uh, yes, sir.
What
The
does it mean
presentation
from the
is,
figure?
sir, the presentation is not visible.
Now visible? Is it visible or not
Uh,
visible?
yes, sir, it is.
Presentation is visible.
Yes, sir.
Okay. Tell me. If I say this is my requirement, this is my requirement. Okay. So from the figure, what you can conclude? Aditya, so unable to answer in the classes has a negative penalty. So Bishwajit Ghosh, you got today one negative penalty, remember. -1. Aditya, what is your view what I have given the figure?
Sir, GPS
Bishwajit,
is
mute your mouth, mute your speaker, yeah, sound.
GPS
Now
is
Aditya,
using much more space, I guess, and the ASIC is using like giving us
no.
what we require, like that.
Okay, mute yourself. Devolina,
Yes, sir.
answer. If
Um,
the triangle is the requirement, I have given 3 figures, each of them characterizing the GPS SC basic. So my question is that what you can infer from this type of figure? Any idea? You can generalize English like language also you can express without any technicality also. The signal what they are designing. Suppose these are the prototype I have developed and these are the different prototype I have developed. Then what
mm,
does it mean?
it's is it related to something like memory or something?
Not yet. No. See, I told that this is my requirement. This is my requirement. And if you see the ASIC, that is application specific integrated circuit. I am writing this is application specific integrated circuit. Okay. What does it mean? It means that only the requirement will be captured by the system. No other requirement except this. No other tasks except this. Are you getting point? Suppose you are doing a calculator which will do a plus b. So only this system always do a plus b, 2-number addition. No other application you can do. Are you getting my point? In these cases, if you are doing for a machine for in a ASIP arena, it can do all type of addition, not only a plus b, it may be do a plus b plus c, maybe a plus b plus c plus d, like in this way. So only this requirement not, apart from this, some other requirement can be fulfilled, but at a minimum scale, not huge scale. If you are planning to addition, it can do apart from 2 bit, it can do for 3 or 4 also. It's application specific. That means application is the addition, any type of addition, any type of addition. But in this case, is only 2-bit addition, not any type, not any type. Are you getting my point? Not any type, only the specific requirement. So it is completely hardware. It is completely hardware. That means you can say in application integrated circuit, very fast for only that application. No other application you can make. So that is the ASIC, and it is a completely chip based. If in your chip it is perform only JPEG coding, so it can do only JPEG coding only. No other coding can be possible or viable using this chip. Understand this point? Clear?
Yes, sir.
If you make, this is the coder for image processing. So not only JPEG, apart from JPEG, you can do other type of application also. Apart from JPEG, this is a JPEG, but you can do other coding also. That means for coding purpose. That means it is only full purpose basis. Purpose, or you can say all the purpose of the same domain, application purpose. If you do codec, all type of codec only, not codec other than codec, you can't do anything. Only coding, codec application. Here, only that specific codec. Clear? If you are prepared 2-bit summation A plus B, only 2-bit summation ASIC can do. No other summation can be applied. But if you make ASIC, it can do any type of sum. 2-bit also it can do. Apart from 2-bit, other parts also it can do, but only sum. In case of GPS, it is for sum. Apart from sum, lot of things you can do, maybe multiplication, division, calculation, so many applications are there. So that's why this is general purpose. Here maybe printing is not also there. Here maybe printing also there. So that's why general purpose is the main term is that flexibility. It is the main task is flexibility. Here flexibility also there, but comparing this the less flexibility. Also little bit programmable features because you can do others also. Clear? Here no flexibility, no programmable features, only hardware applications. Is it clear? So it is fully an requirement, no other requirement possible, only the requirement will be 4. Is it clear? So if I say GPS criteria, I will say our general microprocessor. All the microprocessor comes under this general purpose. If I say a preprocessor, you find the microcontroller. For different microcontroller for different application, you will find out that's come in ASIC. In ASIC, it's a fully particular chip. Okay, if you make a single bit adder, then only single bit processor. If you do 2-bit adder, then 2-bit processor. No other than is possible. Okay, so this is the one area where we should work. Now, if we consider a particular processor architecture, actually processor architecture will may be present in our microprogram also. You will find two very important things. What are the very important things? That means, you know, in our if you notice our main computer architecture in the previous class, you find that there is a data path unit, and there is a control path unit. Am I correct or wrong? And control unit always control the control this signal of the data path. What happened in a data path? Tell me, in what present in data path? In the data path consists of what? Basically you take ALU and some combination of some register. Am I correct or wrong? This is nothing but the our AL register can be scratch pad inside it, or maybe some register, big general purpose register, or you will find some programmable register. That is my part for data path. And you will find in case of control unit, what control unit you will find one what I can say here you will find one control unit, and control unit always influences by two special register. One is I instruction register, one is PC. Apart from this, so many registers are there, but I am just specifying that program counter and instruction register. And those all are directly involved to our memory. Memory
Sir,
also can, yes.
so apart from the ALU, sir, what is the other register in the data part?
Data path is a scratchpad, or you can say general purpose register.
Okay, sir.
Is it clear? Which is used for programmable or you storing data like in this way.
Okay, sir.
But in program counter, you can't program. IR, you can't do anything. Though there is no user interface. It is done by the automatically system. Am I correct or wrong?
Yes, sir.
Those are, comes under here, but it has a lot influence on the control unit only. That's why they are assured the control I have mentioned. Okay, data path, I am mentioning only all those units which handling the user inputs. Okay, and to synchronize the operation of the all the user inputs, I think you need some special controller unit which will be already assisted with the instruction register and program counter. And program counter instruction register is a special registers which you, though program counter contents you can do with the programming instance, but it automatically driven by your program, but the contents is altered by itself as per the program requirement. You randomly can't do all these things in the program counter. But in Sketchpad, you can write multiple times, delete multiple times, all these things, there will be no problem from your side. Is it clear? Any idea, any objection? Or can I proceed? Suppose a program is there, total equal to 0. Okay. And I have written for I equal to 1 to k. I have to go. Then what I have to do? Do total equal to just plus equal to, I'm writing total plus a of I, something I'm writing, and like in this algorithm I'm mentioning. In these cases you will find that register stored the content of the AI. It can, I have to load to the memory, a particular from the memory, and the from memory individual contents will be loaded to the register. And also, since von Neumann structure data and program are stored in a same memory location, that means stored program concept, so program can be accessed by the control unit and data can be accessed by the data unit simultaneously. So this is the actually overview of the the power of the processor that time. So only one part is there, that means one instruction will be executed, so program will be for only sum. Program will be for only what purpose? Sum. Only for this sum the program unit will work. No other applications possible. Just 1 minute. Can you explain, Ochishman, the power of processor depend on what factor? Power of processor. Am I audible?
Yes, sir.
Okay. Ochishman, are you there?
He isn't in class right now, sir.
Okay. Abhishek, are you there?
Yes, sir.
Okay. Can you explain what is the that means in which factor the power of processor depends? The power of processor depends on what factor?
Sir, is it the cache size?
No. Any other students?
So the speed of the CPU to process a particular program.
Not getting. Can you repeat it?
So
Clock
the,
speed, number of cores,
so
Number
the
of
speed of the CPU to process a particular program.
Clock frequency.
Clock frequency.
A clock frequency.
so
So one is
CPI,
taking clocks, another is the cache, another one what?
so number of cores,
Number of cores,
Clock frequency.
frequency, any
The
other?
speed of the
so CPI,
CPU.
sir, clock cycles per instruction.
Clock cycle, any other?
So power supplied.
Throughput and the latency.
So tell me why Intels are more popular in case of this processor domain. Suppose I found a processor in the market which can do 5 tasks. Maybe clock cycle apart from what we are telling this thing, clock speed, cache, number of cores, frequency, clock cycle, all are same. I found processor A and I found processor B. Processor A made by Aditya, processor made by Prajata. Okay. All these are the same thing. These are same. Now my question is that processor A have 5 instruction, processor B have 20 instruction. But all these factors what we're telling all are same in case of A and all case of B. Then which one will be more favorable to you if you are considering that I will go for the general purpose system? General purpose processor. I'm not telling any application specific. I'm doing from general purpose criteria. Which will be more
B.
favorable to you?
B.
Why?
B.
Because it can
More
process
number of
a
instructions.
number of general processes in the given time.
So whatever you are telling that what you are telling that the power of processor both have same. So then during the purchase you are thinking another parameter. Why not all these things? So I made all these things similar. Reason is that power of processor does not depend on these things. The power of processor depends upon, I think in the very beginning of the classes I mentioned this thing. What is this?
Instruction set architecture.
Yes.
Instruction set architecture.
The power of processor fully depends upon the number of instructions set it's apply and how these instructions are processing. It may be 6, it may be RIS. So based on your requirement, if you have some requirement that you will do lot of calculations and lot of multiple, then automatically the choice of the instruction is the more important factor. 6 is complex, comparing the rigs. Rigs are very faster than simple. Then again you can choose which architecture is so suitable, rigs or 6, but it is actually the ISA. Instruction set architecture. Power of processor always defined by its instruction set architecture. Because depends on the complexity of the processor, it defines the complexity. If you have only suppose one instruction to be processed, the architecture will be very simple. Only one data memory. Data memory size will be only to occupy only 1 bit information. If you have a 2-bit size, then data memory size should be 2-bit. Just I'm telling in the memory capacity. In the memory capacity, how it is influencing the number of instruction to be loaded. If you have a 3 instruction, the program memory size, that means our memory should contain 3 locations to store the 3 instructions. So automatically the hardware requirement will influenced by this one in case of memory, as well as if the number of instructions are more, then the control unit design also influenced by this number of instruction. That means the control signal to be generated. The architecture will be completely different because the complexity depends on the processor which comes from the control path and data path. And since number of instruction influence the control and data path, automatically by default it influences the ISA. So ISA is the main thing which defines the power of the processors. Clear? Is this plus clear or not clear? Tell me. So now we understood that ASIC. ASIC is completely hardware. Am I say or not? ASIC is completely hardware oriented. No program feature. Hardware oriented and no programming feature. This is the last class probably in the domain of the computer architectures or hardware. After that, no more class will happen in this domain. So whatever you have started for first semester digital logic design, in fourth semester computer architecture, and finally embedded system. These all things in different semester give you the complete exposure to the computer architecture as well as the you can say hardware field. So anything which is not understood by these things must clear in the earlier classes not understood by you, clear it now. So ASIC means no programmable feature. Directly it is hardware oriented. Okay. SIP. In SIP you find if you see the digital camera also, where you will find this some programming features are there. That means you can change the focus, focal length. Is it possible or not? Some programmable features in that. I am not more telling that changing the more only the lens. You are focusing the object. I am not telling this one. This is the hardware part modification. But I am focusing. But I am also telling there's a programmable mode also there. The different programmable you can set, and then you can do according to your customization. If it is ASIC, this type of feature must not be present there. In the here also hardware and software, but very few, or you can say less consumption called to the GPP. So the program feature is present there. So I found there is an ASIC, there is a programmable feature. Very important point to be noted. Some programmable feature is there. In case of ASIC, is it clear? If I go for the ASIC as the best example that I can design you single purpose processors. If I make a single purpose processor, that means this processor will do only one task. Only one task. That I mean a single purpose. Only one task, no other than is possible. Okay. And finally, you know, general purpose processor. These are the all different type of processors. Okay. And general purpose processor instruction set is very large and represented generally general purpose processor. We may mention that microprocessor. So whenever you tell about the term microprocessor, in your mind it should come that you are dealing with the microprocessor, that is a general purpose processor. But when I go for the ASIC, you remember that I am dealing with the microcontroller. Why microcontroller? I will. It is powerful in his domain. It is more powerful in his domain, but less flexible in comparing GPP. This point is clear.
Yes, sir.
Now we are moving actually what happened in the microprocessor. I am writing the microprocessor. So microprocessor what? It is a general purpose processor. If you notice the actual schematic diagram of the general purpose processor, you will find that in the general purpose processor, there is a must be a some control unit, can I say, which will sequences the operation. Then you will find an ALU, arithmetic logic operation. So I'm writing ALU. And you will find corresponding one register set. I am saying GPR, or you can say this is the scratch pad. Okay. And finally, you will find some special purpose register, that is PC, IR, or maybe status flag. You can say status flag or zero flag, like in this way. Some special purpose register. We also mentioning all the information. These are maybe some flags are bit other and flag bits are there for zero checking, overflow checking, like in this way. So these are, we can say, control register, not general purpose for controlling the operation. You know, some on-chip memory is also there. On-chip memory, maybe cache, mostly cache. On-chip memory is there. So basically, these forms the main control unit of our general purpose processor. Am I correct or wrong? Already we know these are from the data path and this forms the control path. So data and control path. And apart from that, you will find some interfaces. You will get some interrupt. So I can say for interrupt purpose, some port will be configured with the memory. That is our processor. Then you will get
Sir,
some. Yes.
sir, below the ALU, is it the chip menu, sir?
On chip memory. On chip memory.
Okay, sir.
On chip memory. On chip memory mostly it is cache. L1 cache. Okay.
Okay, sir.
L1 cache. Sometimes you can say accumulator also. You can combine here also. Clear? Now in the interrupt you'll get the interface. Interface for external memory also I can use because on-chip memory may not be sufficient. Am I correct or not? Maybe HDD, maybe flash drive, whatever, maybe all this. So this is the interface related to external memory. Is it clear?
Yes, sir.
Then you know some ports. I think in the microcontroller cards also you understand there is a ports for programming. You can programming through the port to the I think some register you can use from register can take data from the ports. You will program the ports and as per the programming the port actually port means that this port is for you. This is the port, but actually you are programming here in your mind. So this is just you can say alias of the GPP. Through this port actually you can program the location of the heralds of the general purpose. So that's why some programmable feature or you can say programmable ports are there. All ports are not programmable. This is the interrupt. This is for external memory. So some ports are there. And finally we have a some clock. We have to some clock to combine the sequence the operation by using some predefined periodic signal. So you can some periodic signal there. Is it clear? Some periodic signals. So if you notice, this is the actually the uh, main processor unit. So if I say processor, you will find that this is my processor. So what actually in microprocessor, these are present. Is it clear? So different database size according to the size of the addressing capability. You maybe 32-bit, maybe you will get you can get 32-bit. You can get up to what I can say 64-bit, 32-bit, 6-bit, etc. Is it clear? So these are the, I think the processor. So in your mind, whenever I say processor, what should be there? Is it clear or not clear, or I have to repeat it? Are you getting my point? What I'm telling? If it is not clear, you just tell me.
Sir, can you repeat again in short?
I am telling that first of all, in the processor architecture, main is data path and control path. What is data path? Data path, we have a some ALU, some sketchpad registers, that is GPR general purpose registers, some on chip memory, on chip memory. So these are the particular data path. You will find some control unit. Okay, I'm doing 30. This is the data path. Is it clear? So data path is the ALU general purpose register and on chip memory. After that, you now go to the control unit and you have some special control register like PC, IR. These are the control registers. Okay, then some status bit. All these are present. Status flags are there. So we can mention is a control register. Is it clear? Now this entire combines in a single chip. Apart from that, the chip has some interface. That is, I can say this is the interrupt, which interrupt signals will be booked. Then you will get some interface to the external memory, okay. Then you will get some port. This is the port, and this port for your programmable port, very important, because during the programmable the cache pad or register we use programmable port, and there is a clock. Entire this entire comes under the our microprocessors. Clear? So this is the basic structure of our microprocessor, or you can say this is the example of the general. What actually general purpose register contains? This is the basic fundamentals. So you will understand what happened. So when I say this is a microprocessor, this should be present. But problem is that in microcontroller, microprocessor is there. If I go for the microcontroller, a microprocessor there. Can you say this is present here? No. This is the general purpose which can have 32-bit, 64-bit capability processor. But in when I consider the microcontroller and microprocessor, maybe 16-bit, maybe 8-bit, like in this way capability. So the microprocessor used in the microcontroller have some generally less capability than that microprocessor. But microprocessor is there plus something which is not present here. So now if you notice it, that I have a microprocessor in my computer. Now microprocessor, there is a bus, in the bus, hard disks connected, cache, multi-level cache is connected. If you go for the DMA, then DMA is also notated. If you some converter, then go for the AD converter. If you have some printer device, printing folding application, then you go for that architecture, all these things. Now these are all our activity with the some port configuration. These are the for port purpose. You will find that here mostly the microprocessors are applicable. So these are the actually microprocessors. Apart from the microprocessor, whatever I have explained in this part, this is the microprocessor. This present here. But apart from that, you know, all these are connected. All these are different things are connected. Clear? Not single chip. In this is the only single chip, and these are isolated. You can connect. You can run a flash drive also. You can connect another processor architecture also. Multiple all these things are connected to them. In general purpose processor, you will find as per requirement. You can add LAN card. You can graphics card additionally. You can do a lot of things. You can add it. So the flexibility will be high. So the modification, upgradation, maybe RAM size you are now increasing, early comparing other. So this is the possibility in the microprocessor. But when you come microcontroller, you just remember that in the microcontroller, particularly this is the ASIP. ASIP, that means application specific instruction processor. So earlier it is not application specific. Now we are entering the application specific. So what you will get? You will get a, this is a system on chip also, you can say this term. System itself on chip. Be careful, everything on a single chip. What? There will be a processor, I can say microprocessor, but it is a very small scale application. Small scale processors, I am telling. Maybe 16-bit, maybe 8-bit. Nowadays, 32-bit microprocessor also used here in the microprocessor part. But it is less powerful than general purpose. Be careful. If it is required general purpose, then my cost of the product will be very high. Since it is application specific, so you should have familiarity. Am I audible?
So
Okay. Any term not clear, you just tell me, because during the designing, all these parameter comes in your mind. So not clear, you just raise your voice. Just I will take 10 minutes because I lately started. After this, do you have any classes? No class, I think, na? Any classes are there?
No, sir. No, sir.
Okay, that's
No,
why
sir.
10 minutes I'll take. So you should have familiarity. Why I am telling familiarity? Suppose you are trying to design an embedded system. Are you getting interest or not? Whatever I'm explaining,
Yes, sir.
or
Yes, sir.
little bit boring,
Yes,
na?
sir.
भाई सर को फ्लर्टिंग मत
No,
करो,
sir.
बोरिंग लग रहा है क्या?
Okay. Sir, interesting. Sir.
अरे जहां पे बोरिंग लग रहा है वहां पे रेज करो सर बोरिंग. मेरे क्लास में ये भी बोलना मतलब जायज है. बाकी क्लास में आई डोंट नो, बट मेरे क्लास सर थोड़ा बोरिंग हो रहा है lecture. You can teach this also. I am giving the flexibility. I will never think of this matter. Whenever a student get bored, whatever I am telling, it will be that means very wastage of my time and your time also. So I don't want thing. If you get little bit boring also, I will modify the lecture. You get raise your voice. So little bit sleepy. Directly can't say boring, but sir little bit sleeping. I understand whatever mentioned. So whenever you are designing the embedded system design, you must be familiar with the processors. Otherwise, choosing the microcontroller also very dangerous for you, because you don't know which microcontroller will be best suitable for you. So you should have some idea of the microprocessor, because microcontroller itself some microprocessor. So suppose you are using only 4-bit instruction, and that's why I think 4-bit microcontroller is have sufficient, microprocessor is sufficient. Think about the microprocessor part. So I will consider that microcontroller which have some 4-bit microprocessor. First is this is the thing. So you should have familiar, and you are thinking some microprocessor which still not available in the market will come very soon. Don't design your embedded system based on that future applications or future AI based applications something. Whatever all the available microprocessor in the market, based on that familiar microprocessor, you are habituated also, you should start design. This is a very critical experience whatever we faced design that during the design. You don't have an idea, don't think, sir, if we have, if you have the 16-bit, it will be better. Don't think like in this way. Whatever you have in your design, within this you try to design. Clear? So microprocessor will be there. Plus, what are the plus? Another features at the timer. I know clock is already there. Microprocessor clock is there, na? In the microprocessor itself, clock is there.
yes, sir. Yes.
So clock is not my headache. My headache is another thing I am added, timer. Very important thing. Apart from this timer, then you will find some A to analog to digital, digital to analog converter. Okay. Then also some on-chip memory. Why? I mean microprocessor itself some on-chip memory is there. Why you are mentioning on-chip memory separately? Here, because there is a chance in case of embedded system that I need program memory and data memory should be separated. That means what I am targeting architecture, Harvard architecture I am following, not von Neumann. Are you getting my point or not? In Harvard architecture, data and program are separated, but in von Neumann, in a single memory. In stored but single. That means in von Neumann architecture also, it's a stored program concept. When you go for the von Neumann Princeton architecture, you will find data and program should be stored in a single memory. Whatever in Harvard architecture, it can be separated. For the purpose of your design, sometimes separated data memory, separate programmable memory may be required. So speed will be enhanced, though the area will be more, but speed of the device will be increased because they are using separate that means bus line to access data and program. Is it clear? After that, some communication port, very important, because some applications actuator or some signals sensors should be communicated with this one. So some communicated ports will be there. After also there are some special ports are there. We can say this is the specialized instructions port. Actually, these are for bit manipulation, used for bit manipulation. So now all these features in a single chip. So from looking the comparing the microprocessor, You can say the sir, this will be more powerful, but I am telling it is not more powerful than my Java, not so much flexible. Can you say why? Can you
Sir,
say why?
repeat the question, sir.
I am telling that here also microprocessor is there. Apart from microprocessor, so many things are there. So I can say whatever I have previous studies, that means this one, my microprocessor. So in microprocessor, microcontroller, I am getting one microprocessor also plus more. So my this will be more powerful. Can I say?
No, sir, because microcontroller is doing only one task. Microprocessor is general purpose.
General purpose, you can say the microprocessor used here not have so much power or capability than the other microprocessor, because we are choosing the microprocessor here based on our application only.
Yes, sir.
The general purpose microprocessor may have 64-bit microprocessor, but here maybe you are using my 8-bit processor. So 8-bit processor capability not be same as 64-bit processor capability. So sometimes students are confused that since I have a microprocessor here, some additional, why not is powerful? Actually, it is powerful in its application only, because these features are on chip. So on chip memory, on chip application is always faster comparing this previous one. All are connected in with some bus or cable line. That is not on chip. But in this care, you will get this on chip applicable. So that's why it is a little bit system on chip scenario. A system completely built up on a single chip. I can say, am I getting? But since other parameters also there, so I can't say it is an entire system. But I can say in the little bit scenario that it is application specific and all these things are present here. Am I clear at this point up to this? So whenever you are choosing microprocessor, apart from ISA, you have to choose the speed. Very important, because that speed also will also help us to choose the microcontroller area which microprocessor required. So speed will be managed by the clock. Also instruction cycle per execution IC, instruction cycle per execution, and that also followed which architecture, either MIPS, million instruction per second, or spec benchmark, which architecture, or Dheistun is another architecture specially applicable for the processors, and spec is desktop oriented only. MIPS can be applicable for general. So any architecture whatever you are following during the enhancing the speed depends upon that architecture. Then also of the power consumption consumed by the microprocessor is very important. If it is a battery based system, so choosing the microprocessor for the embedded application in the field of the microcontroller is a very important field. Then also you will find the size. Size is a very important field, and the cost of the product, that finally I can afford it. Otherwise, I can choose that microprocessor. This is the choosing of the microprocessor. Now, if you go for the choosing of the microcontroller, then microcontroller completely you have to choose your application, which will solve the application, and application, that means all the application in all these domain, all at that domain. I'm saying is if addition, all type of addition, not only 2-bit addition. So the processor application should be chosen like in this case. So I can say whatever I declared microprocessor plus additional some features are there, like analog to digital converter, analog to AD converter, timer. I will explain timer next class, why timer apart from the clock is very essential. Then communication port, then some other interfaces. These are combined in a single chip. So there's the concept of the microcontroller. Now it is clear between a distinction microcontroller and
One
microprocessor.
doubt, sir. One doubt, sir. Sir, in case of
Yes.
the microcontroller, sir, are like in case we are doing addition of 2 bits, sir, uh, does that also include all other forms of addition for the microcontroller and the microprocessor? Only addition of 2 bits, or is it the opposite, sir?
In microcontroller, if you are doing addition, the processor you choose based on the capability processor, it will do all type of addition. Maybe your processor can process up to 5-bit, 4-bit.
Yes, sir.
So 2-bit to 4-bit, all type of addition microcontroller can do.
Okay, sir.
But in microprocessor, if its size is 64-bit, it can go up to 64 bit, anything, but you can't increase here. Because the microprocessor, whatever used in microcontroller is less powerful than general purpose.
Okay, sir.
Otherwise, cost will increase. I can, if I enlist general purpose here, the cost will be huge. You are making suppose you are making the speed controller, just speed of the tire based on the friction of the road, the speed of the tire, you will be controlled. So the microprocessor only process, I think, 2 or 3 instruction. One is the frictional parameter, one is the current speed parameter, and one is the altitude parameter, maybe. Only these 3 instruction it will process simultaneously. So I think 4 bit will sufficient. Using 2 bit, you can do 2 to the power 4, 2 to the power 2, that means 4 instruction at a time you can do. Suppose the 2 bit microprocessor is sufficient. Am I cutting or not? 0 0 for altitude, 0 1 for friction, 1 0 0 for speed, and 1 1 maybe left for accelerating, whatever maybe. So this combination will in combine different set of instruction. So the microprocessor used here will be only 2-bit microprocessor. But if you use a computer here, your laptop 64-bit capability. Now the cost of the laptop, I think around nowadays at least 30, if required 30,000, and the microcontroller required here maybe 5,000 or 4,000. If you use that microprocessor, the cost will be more than 30,000 also. Are you getting my point or not? So that's why that microprocessor you can't use here. You have to use such microprocessor, the product of the chip, which I embed in the system of the car, will be very less comparing this one. Am I clear at this point? Any doubts? Or am I not clear? This question is not still clear.
Yes, sir. Clear, sir.
What was it actually your question? Can you repeat it again?
Sir, actually, I was confused about which one was more powerful, so microcontroller or microprocessor. And actually, I
I
had
am
the
telling
question.
microprocessor is more flexible. Microprocessors used in case of general purpose scenario. In case of general purpose scenario, I'm telling.
Yes.
For desktop, PC, laptop are more flexible. More flexible, even you can say more powerful, because it can do multiple operation. But it is not, I can say, performance. When you go the performance oriented and particularly specific tasks, because this is the ASC IP, application specific. If you go application specific, that time microcontroller is powerful, because only that application you'll do. That speed of the tire will be controlled, and laptop also do. The cost of the laptop is more higher than that this time. So cost, what I have mentioned already, that power already defined by the so many parameter, that speed, power, size, and finally this one. This is a very important field. Are you getting my field or not? This cost. If you can use general purpose also for that embedded application, the speed of the tire, but the cost of the system will be higher than this of this one. Also portability will be issue, because laptop always you have to carry and connect the laptop with the system of the car. Every time laptop will be on, usually power driven. So portability and lot of power issues will be happen in case of your uh, general purpose application, if you would like to use for embedded application. But here the cost will be very less, because only a microcontroller chip will be embedded with the system. So portability, all these features which is suitable for the microcontroller will be that time powerful. Clear? If you check the flexibility part, then general purpose always more powerful and more flexible. If you say only application specific task, then microcontroller will be more powerful in terms of cost and performance. In terms of cost and performance. Are you getting my point?
Yes, sir.
Now I think clear all of you this point. So tomorrow, from day after tomorrow, we'll directly go one example of the single instruction processor and digital signal processor. After that, one more topics will be there, that is how to design a processor, single instruction processor. That is, you can say today we'll go for the ASIC world. I have to design on ASIC. ASIC also, you understand that with the application of microcontroller, maybe you have seen, I think, Arduino board. Arduino you have seen, I think, very small scale.
Yes, sir.
And
Yes.
there also you will find one on-chip microcontroller is there at Mattel.
Yes, sir.
Atmatel itself has a processor unit will be there, must be there. In the Atmatel, a processor unit will be there, and all other fields are with the connected with the Atmatel. So this is the one I can say best example of microcontroller based architecture. So instead of huge laptop, that Arduino board can solve your purpose to do the tasks. Is it clear or not? And the cost of the Arduino board is only 500. You just programming do the application of the Arduino board. At least by giving some input to the pin of the communication port of the Arduino board, your purpose will be solved. Maybe indicator, left, right, indicator, maybe wiper, rotor motor on and off, so that single Arduino like board will solve the purpose, and it can be fixed anywhere in the car's electronic circuit very easily. Size is very less compact. So based on this requirement, that microcontroller based application there. So whenever you are coming on the domain of the application, I'm telling particular application, I will not use the processor used in the washing machine. I can't use the processor in the AC, or I can't use the processor used in the AC. I can't use in the car, because these are different application. So based on the application, you have to choose the microcontroller or maybe the processor used in the microcontroller. Then automatically the cost, size, all this will changes. But in the domain, if you are coming only application specific, that time flexibility is not my requirement. My goal is that whatever task is assigned to me, I have to do. Suppose I am teaching 5th semester classes, my task only embedded system you have to teach. So in embedded system domain, you can say I am powerful and my performance is best. Now if I start teaching OS also, if I touch all these things, automatically little bit performance will degrade. That's why you are getting different faculty and different, you can say these are all SIP. All are SIP. So power you will get the best session from all the faculty. If a single faculty all these subject teach, I think little bit that means performance will degrade. Am I correct or wrong?
Yes,
True or
sir.
false?
Yes, sir.
अरे ये भी बोलने में डर क्यों लगते हैं तुम लोगों को? Okay, so this is the up to we are finishing. Every day I am finding 131 to 140 students are regularly attending the classes. So your strength is 84. I don't know what will happen 150. I will cross check the attendance, and before that only those module account this time will be activated, because we are habituated with the last 1 year to the online examination. This time I will not show any mercy. Be careful. Attendance is less than 75%. You will not be eligible